Hello, my name is Dante De Niro, and this is my Lab 5 demonstration. So for the IPAM software I use something called NetBox, which is just an open source IPAM. Can do a lot of different things. You can log devices, connections, um, IP addresses, which is the biggest thing. It also do like VRRP matchings, but I mainly just use this for storing IP address information for each of the different devices. So if you click on R1 here and go to interfaces, you can see that I have all of the interfaces from my device and then all of the respective IP addresses from that device. So for like to add something like this, you can just do bulk add, and then you can just give it a CSV like formatted object. So something like this is how you kind of add different devices. These are like the table names, and then the different values you want for the respective names. So like name R1, R2, R3, R4, and then the different status, tenant site, location, kind of blank, and then like the role it has. So I made them routers. All of these are customizable. So router is something that I just created, and then manufacturer. So and then you can do a similar thing for the different interfaces with just another CSV like object. And then again for the IP addresses. So all of this stuff was added in bulk to this using something like a bulk import. And then it all just kind of filters out here. And then you can see the different IP addresses that were assigned to each thing or each device. I am then using so from there, I created a script that will fetch that information via NetBox's API. So you have to include a device ID and then the interface ID, and then that will return the IP address after some parsing. So this function here is creating the request and sending that request, and then parsing that information. So it's just returning an IP address. And then I am establishing that information within my main app. So this is essentially just calling that class from that script, populating it with the URL and then the token used for logging into NetBox via API, and then I am just sending that sending the device type that I want, and then that will be used up here in the device name. So that device name will pull from this self.devices. I'll get that list of items, and then it will realize, okay, called R1, run this device ID on that interface ID, and then return that value. So I can save that into a variable, and then I can send that variable down here for my dictionary of devices that can be used for later processing and my other functions. Um, so that's kind of my IPAM system. This is largely just containing the different devices I have and the IP addresses that are assigned to each device. So for password management, in my main app, I am just opening up a file that contains the passwords, reading that file, and then separating that data via the colon point or colons. So we'll be able to parse each one. So passwords will read this, will initiate that function. This will store a list of all of the different device names to password matchings. So R1 will get the password comma separated or colon separated, and then be able to save that password to a function again. And then again, I'm sending that function down here to devices so that I'm storing that information in a dictionary so that I can use it for further, so I can use that to log into the different devices automatically. So for my passwords, I am just creating a random string of letters and digits, making it completely random, and then saving that to a file. So down here, this will call, this is what I want each of the devices to be. So R1, go through R1, it will call this generate random password function, which will come up here, generate a random password, and then that password will be saved to a file. So that file functions here. Just open up that file, write that to a file, and then you'll have your password file. So the password.txt, it'll look something like this. And then this will be ran in a cron job alongside the change password script. So again, this is doing something similar to my app, to my main app. Just going to open up that password file that I created over here. Again, split those lines, parse each device name and password, and then save that to a password variable. So I'll create an empty dictionary and then return that after I'm done with the processing. And then down here, I'll call that function with passwords and then save that to a variable. And then I'll have just basic admin information to log into each device. This will, the host device name, and then host will be pulled from up here. And then that will read through that and then log into each one of the devices. And then I'll get my new password again from password stock get. So that will invoke this function here to run that, to read that, and then run a loop through each of the devices. And then I will log into each one of the devices, set that new username, which is just the default. I just created a new user, net user. So that will be for each device will have net user, and then the randomly generated password that was pulled from the password.txt file. So that both pass gen and change pass will run in a cron job. I believe it's every day, I think, at 2 a.m. So this will pass gen will run at 2 a.m. and then change pass will run a minute later at 2:01. So every day that password will be changed, and then this will be updated. So when this is reran, my app.py is reran, it'll grab that new password file and then use that to log into the device. So that's largely the password and the IPAM solution. Moving on to Jenkins. So for Jenkins, I ran this on a different on our different Ubuntu machine. Largely because it takes up a lot of different space. So I'll kind of go over my Jenkins file. So for the Jenkins file, basically just ensuring that all of this information is installed, or all of these different modules are installed for pip, and then I'll run black and pylint against those files to ensure that the formatting is correct, and then there's not any large formatting issues. So that's what these two are doing. Black is checking all the basic Python scripts, and then this is checking all the Python scripts that are within a folder, and then pylint's doing the same thing, checking all the files and then checking everything that's within a folder. And then running that against every one of my Python scripts. And then lastly, once those changes are made, it will do a git config, and then a git add, and then a git commit, and then finally do a git push. So I'll push those updated formatting changes back to my GitHub page, so we can kind of show that working. I just have a git test, so I can just change this real quick, and then just to show that it invokes a test. So anytime I make changes and update it, so I can send from here too. If I do any of these git pushes from here as well, this will also invoke Jenkins to be run on the newly created or newly modified Python files. So it could be either from there, but just for testing purposes, I'll just show you it being ran from here. So if I do commit change here, I have again a webhook on my GitHub page, and it sends to this machine using ngronk. So I just have an ngronk session running that is just using my private IP address, making a public IP address or public link, and then having a webhook on my GitHub page. So anytime a commit is added, it will invoke a Jenkins job, and then it will run. So ran successfully, and it's just basically ensuring everything's installed correctly. And I have the latest version running black on every Python file, and then lastly doing a pilot on the more important files. So I can kind of see my score, what it's rated. If I need to make any, if this is really low, maybe fix the formatting, make some changes, and then again doing a git push to push everything back to GitHub with the changes and everything like that. So that's kind of my automated pipeline Jenkins solution. Eventually, I'm planning on kind of moving my project over to this VM. It's just kind of hard. I got a lot of different things kind of running currently. So once I do that, I'll be able to, do more like IP connectivity to make sure I can reach everything initially before I run, my main app, just to test connectivity to make sure I didn't break anything with my Python scripts, just to ensure I still have like management IP connectivity. So that's kind of that solution for the automated Jenkins pipeline. Moving on to some of the health checks. So here I'm largely just running some show commands to ensure that different things are running and that the neighbors are consistent, so that I can quickly click on my website to show that, okay, I still have the correct neighborship. I can still ping my management port, or my management IP, and other stuff like CPU utilization to make sure nothing's running hot. So yeah. So what's largely going on here? I started to invoke the Arista API. So this is a module that you can use. All you gotta do is just specify an IP address, which is from that above dictionary, username and password from the device, again from that dictionary that was previously shown. And then you can run some API requests. So these are the different API requests. So I used it for route and CPU utilization. And then I sent that result to the results, which will then parse that information to health check. So health check will then load an HTML page with all of this different information on it. And I am, again, going through each one of the devices, so 4 devices, so I'm using that whole dictionary to go through each one of the devices. And then this is just some of the parsing that I'm doing here. So I'm just parsing it to make the formatting a little easier to read and understand, and then that's being called up here. So the different parsing will happen here. And then these are the commands that are being sent for further parsing. And then again, I was using the Arista API for the routing table and then the CPU utilization. So basically just logging in, saving that output, and then passing that output to healthcheck.html in order to show it on my web page. So we can kind of just show what that looks like. Click on health check here. So that was successful. So basically I parsed that output just to show that everything was, the transmitted and received, and then the loss percentage to show that I do have full connectivity, or if I don't have full connectivity, you might not see this. You'll see 0 out of 5 and then 100% loss. And then you see a list of my different neighbors for OSPF, and if it doesn't have OSPF, it just won't show anything. And then same kind of thing with BGP. You'll see the different neighbor relationship, the AS they're involved, the state, to make sure that everything is established, and I'll know that everything's good to go and there's not any problems there. And then the whole routing table. So I'll have the different routing tables for each of the devices. I could potentially clean this up a little bit, but there are a lot of routes, so I don't know how much better I can get this to look. I basically just have the route, the protocol, and then the next hop. So probably the most important information there. Um, and then you can kind of see, if anything's changed. And then lastly, you have CPU load. So this will just get the CPU load averages of each one of the devices to make sure that, nothing is getting overloaded. So yeah, that's just basically how the health check stuff is kind of looking, all in kind of one nice. You can kind of do a control F and look for specific things. Eventually you could probably save this to a file as well and then do a diff to, if the diff is different, maybe you can look at that and be like, okay, a route change, lost neighborship in one of the between one of the neighbors. But for now, it's just kind of on a web page showing me different, kind of the more important things here. So yeah, that is kind of an overview of everything. And thank you for listening. Bye.